So today we will discuss from question number 15. So in question number 15, in a two-layer soil system, the top soil and the bottom soil are of same thickness. The top soil and the bottom soil are of same thickness, but the coefficient of permeability of the top soil is twice that of the bottom soil of coefficient of permeability K. Okay, so there is two layer. The soil is in two layer. Okay, and the top soil, this is the top soil, this is bottom soil, this is top soil, this is bottom soil, it's of same thickness. So if it has thickness h, then the bottom soil, bottom layer have thickness h. Okay, both have same thickness, and the permeability of top soil is twice, so its permeability is 2k, and the bottom soil permeability is k. Okay, so we have to find uh, when horizontal flow occurs, the equivalent coefficient probability of the system will be. So kh, we have to find kh. Kh is k1h1 plus k2h2 divided by h1 plus h2. So k1 is 2k into h1 is h plus k2 is k and h2 is h. So and divide by h1 plus h2 divided, this is h plus h. So this is 3kh divided by 2h. So this is 3 by 2k. This is 1.5k. So 1.5k. Option number B will be the answer. So 15B. Okay. Next is question number 16. So in question number 16, which one of the following diagram represents the effective pressure distribution for a saturated soil mass of depth z submerged underwater of height z1, um, and so which one of the following diagram represents the effective pressure distribution for a saturated soil mass of depth z submerged underwater of height z1 above its top level, and gamma prime submerged density of soil, and gamma set saturated density of soil, and gamma w unit. Okay, so this is, we have to represent the effective pressure distribution. Okay, so effective stress, we have to find effective stress. So a soil, this is the soil mass. Okay, and above it water. Above it I'm taking different color. This is the jet depth. This is water. Okay, at this depth there is only water, and this is z1 actually. Okay, and this is z, this is z. Okay, this is z depth, this is soil. Okay, this is soil mass, and there is standing water of z1 depth. So when you draw the effective stress diagram, then the effective stress, you know that effective stress is total stress minus pore water pressure U. So from this point to this point, there is only pore water pressure, and this will be equal to a total stress. Okay, so from here to here, effective stress will be zero. Effective stress will be zero from here to here, and the effective stress um, will start increasing from here, and the diagram will look like this. Okay, the diagram will look like this, and this is Z into gamma submerged. Z into gamma submerged. Okay, so the answer will be A in this case. Okay, because in this range, this will be 0, and for this range, mm, effective stress is equal to total stress. So if you see at this point only, at this point, at the bottom, at this point, then you will get sigma total stress. Total stress is mm, total stress is gamma sat into gamma sat into Z minus gamma W into Z. So if you take common, Z has common, then this is gamma sat minus gamma W. So this is Z gamma submerged, and Z gamma submerged, this is gamma prime. Okay, so this will be the option A will be the answer. This is question number 16. Now question number 17. Effective vertical stress at some depth below the river bed is unaffected by the water depth in the river. Yes, this is same as question number 16. Okay, this statement is correct. And the second statement reason is equal amount of increase in total stress and pore water will not change effective stress. Equal amount of increase in total stress and pore water pressure will not change in effective stress. Yes, this statement is correct. And this is the explanation of assertion. So option A will be the answer. Okay. So 17, A will be the answer. So question number 17 is done. Now question number 18. Question number 18, assertion A. Permanent lowering of, sorry, permanent lowering of groundwater table results in settlements. Yes, this statement is correct. Permanent lowering of groundwater table. If groundwater table goes down, then effective stress is equal to total stress minus U. As groundwater table goes down, so the pore water pressure will decrease. And as pore water pressure decreases, the sigma effective, that is effective stress, will increase. And as effective stress will increase, okay, this is as sigma goes down, this implies that effective stress will increase. And as effective stress increase, this implies a settlement will increase. So this statement is assertion is correct. The reason is increase in effective stress result in settlement in soil. Yes, this is also correct statement, and this is the correct explanation of assertion also. So the answer will be A. Okay, the answer will be A. Question number 18, answer will be A. So as as U goes down, this implies that sigma effective stress increases. This implies that settlement increases due to due to due to permanent lowering of permanent loading of permanent loading of water table, water permanent loading of water table. Okay, effective stress increases, effective stress, effective stress, effective stress increases, which results in which results in which results in settlement of soil. Settlement of soil. Okay, so this is question number 18. Now question number 19. Question number 19, what is this? The following data were obtained when a sample of medium sand was tested in a constant head per meter. Cross section area of sample is 100 centimeter square. Hydraulic gradient is 10, and discharge collected is 10 cc per second. The coefficient of permeability of sand is, so according to Darcy law, discharge Q is equal to Ki into A. Ki into A. K is the permeability, okay, and I is hydraulic gradient, and A is the cross-sectional area, okay. So from here, K is equal to Q divided by hydraulic gradient into cross-sectional area of soil sample. So what is Q? Q is 10 cc per second divided by hydraulic gradient is 10 into area is 100 centimeter square. So from here, that is 10 centimeter cube per second divided by 10 into 100. So 10 get cancelled out. So this is 1 upon 100. This is centimeter square. So centimeter square and this cube cancel out. So this is 1 upon 100 centimeter per second. 1 upon 100 centimeter per second. So the all answer is meters in meters. So if we convert this in meter, so we will divide by 100. So this is 1 into 10 to the power minus 4 meter per second. So answer will be C. Question number 19, answer will be C. Okay, now question number 20. The total neutral and effective vertical stresses in ton per meter square at a depth of 5 meter below the surface of a fully saturated soil deposit with a saturated density of 2 ton per meter cube would respectively be. So 5 meter depth vertical stress at a depth 5 meter below the surface of fully saturated soil deposit with saturated density is this one. Okay, so there is a deposit of depth 5 meter. This is 5 meter. Okay, and mm, this is gamma sat, the saturated condition, and gamma sat of this soil is 2 ton per meter cube. Okay, so the total stress is sigma, total stress sigma is equal to depth h into gamma sat. So h is 5 into gamma sat is 2 ton per meter cube. So this is 10 ton per meter square. This is 10, and u is equal to h into gamma w. So h is 5 into this is 1. This is 5 ton per meter square, and effective stress is total stress minus pore water pressure. This is 10 minus 5 is equal to 5 ton per meter square. So uh, the total, the first is total, so 10, 10, comma, neutral is 5, comma, 5. Okay, and the factor. So 10, 5, 5. So 10, 5, 5, option number D. Okay, so question number 20, option number D is the correct answer. Now question number 21. Or a stratified soil deposit has three layers of thickness. Z1 is equal to 4, Z2 is equal to 1, and Z3 is equal to 2 unit. And the corresponding permeability of K1 is equal to 2, K2 is equal to 1, and K3 is equal to 4 respectively. The average permeability perpendicular to the bedding plane, perpendicular to the bedding plane. Okay, so that is, we have to calculate KV actually in this case. Okay, so Z1 is equal to 4, Z2 is equal to 1, and Z3 is equal to 2 unit. And K1 is equal to 2, K2 is equal to 1, and K3 is equal to 4 respectively. So KV is equal to Z1 plus Z2 plus Z3 divided by Z1 by K1 plus Z2 by K2 plus Z3 by K3. So Z1 plus Z2 plus Z3 is 4 plus 1 plus 2 divided by Z1, that is 4 divided by K1 2 plus Z2 1 divided by 1 plus Z3 is 2 divided by 4. So 4 divided by 2, 1 divided by 1, and 2 divided by 4, correct one. So 4, 5, and 2, 7 divided by 2 plus 1, 3. This is 3 plus 1 by 2. So 7 into 2 divided by 7. So this is 2. Okay. So option number B will be the answer. 21. Option number B. Okay. Question number 21. Number B. Now question number 22. Question number 22. Match list 1 soil description and with list 2 coefficient of permeability mm per second and select the correct answer. So for gravel, it is the largest. The coefficient of permeability will be largest for gravel. Okay, in these three B, C, D, this is the largest. So option A will match with 1, and B will match with, that is clay silt admixture loess and homogeneous clays. So clay have the minimum coefficient of permeability. So D will match with 3. Okay. And Lewis has a high permeability as the clay silt admixture. Okay. So Lewis has this will B will match with C will match with actually 2. Okay. And B will match with 4. So 1, 4, 2, 3. 1, 4, 2, 3, option number D. 22, option number D. Okay. So this is question number 22. Now question number 23. Consider the following statement. Coarse sand is more than 1,000,000 times permeable than high plastic clays. Yes, this statement is correct. The permeability depends on the nature of soil and not on properties of liquid flowing through soil. No, this statement is wrong, because permeability depends on the nature of the soil, as well as it also depend on the properties of liquid flowing through the soil. It also depend. Okay. So because is uh, K is directly proportional to or equal to C times gamma W upon uh, viscosity mu E wide ratio E divided by EQ divided by 1 plus E and 1 upon a specific surface area square. Okay. So this is the property of gamma W and mu is the property of fluid flowing through the soil. So it also depends. So option number 2 is wrong. And now 3, if a sample of sand and a sample of clay have the same void ratio, both sample will exhibit the same permeability. No, this statement is also incorrect because the size, sand will have more permeability actually. With void ratio is same, but the size of sand particle is more. So a specific surface area in case of sand is very less. Therefore, K will be high in case of sand as compared to clays. Okay, because in case of clays, a specific surface area is very less, and due to this, the value of K, that is permeability, will be very low. Okay, so in case of sand, if we see option number 3, then in case of sand, the specific surface area is low, low. This implies that K will be high, given that the void ratio is same for both sands and in case of sand and clay. So in case of clay, the specific surface area is very high. This implies that K will be low, given that for both the cases, given that E for both is same. Okay, so E for both in both the cases, if E is same, then also the permeability will be different for sand and clays. Okay, so statement 3 is also wrong. Now statement 4, permeability of soil decreases as the effective stress acting on the soil increases. Yes, because if you increase the effective stress, if you increase the effective stress, this implies that the void ratio will decrease. And void ratio will decrease. This implies that the permeability will decrease because permeability is directly proportional to void ratio. So permeability will decrease as effective stress increases. So statement 4 is correct. So 1 and 4 is correct. So option number C will be the answer. Question number 23, option number C. Okay. Now question number 24. Question number 24. In a falling head permeability test on a soil, the time taken for the head fall from H0 to H1 is T1. The test is repeated with the same initial head H0. The final head H prime is noted in time T by 2. Which one of the following equation gives the relation between H prime, H0 and H1? Okay, so the in case of falling head permeability test, the value of K will be determined by this formula, that is K is equal to L, that is length of soil sample, into A, the cross-section area of the standpipe, divided by time into A, the area of um, the cross-section area of soil sample, and ln H H1 by H2. Okay, so this is the formula where what is A? This is a standpipe. This is a standpipe, and this is soil sample, and in this we make constant head. This is cross-sectional area, cross-section area A standby cross-sectional area, okay, and this is soil sample, and the cross-sectional area of this cross-sectional area is capital A, and this is length L, okay. So K1, in this case, K is equal to L A divided by time is T into A ln H naught is the initial height divided by H1. Again, the soil is same, so K will be L, length of sample is same, standby cross-section of standby is same, and time is taken is T by 2. And A, the cross-section area of the soil sample remain the same, and L, this is H naught by H naught by H1. This is H naught to H1, and this is H prime. Okay, so this is equation 1. This is equation 2. Now from equation 1 and 2, from equation 1 and 2, this is 2 into ln H naught by H prime must be equal to ln H naught by H1. So this is H naught by H prime square is equal to H naught by H1. Okay. So from here, H naught square divided by H1, H naught square divided by H prime square divided by H prime square. This is equal to H naught by H1. One H naught cancel out from here, and this will be H prime square is equal to H1 into H naught. So H prime is equal to, H prime is equal to a square root of H1 into H naught. So H prime is equal to H naught into H1. Option number D will be the answer. Question number 24, option number D. Okay. So now question number 25. The installation of sand drains in clay soils causes the soil adjacent to the sand drain to undergo which of the following: increase in porosity, increase in compressibility, decrease in horizontal permeability, and decrease in shear strength. So for this question, answer will be C. Okay. So why it is C? Let me explain this here. During installation, during the installation of sand drain of sand drains, the clay around the drains, the clay around the drains may get remolded, may get remolded, thus reducing the value of thus reducing the value of coefficient reducing the value of coefficient of consolidation, which causes decreasing which causes decreasing which causes decrease in horizontal permeability. Horizontal permeability. This is known as seamer effect. This is known as seamer effect. Seamer. Seamer effect. Okay. So the option will be C. Question number 25. So this is all for today. Thank you everyone.